Chris with RC Worst here, and today we're going to talk about how to read a pump curve. And in this video, I'm going to offer a simple explanation for anyone unfamiliar with the pump curve so that you can gain a basic understanding of how to read it. So a pump curve shows, really in its most basic format, two pieces of information. It displays flow and pressure primarily. It is possible, however, for a pump curve to display a greater deal of information, including information about efficiencies, horsepower requirements, and a variety of other information for more particular applications. The typical curve or performance curve for a pump is going to be laid out in a similar format to what we have here. So most commonly, pressure is on the y-axis of the graph and flow is on the x-axis of the graph. So let's take a look here at a real pump curve, and in this particular example we have a bar mesa pump curve. This is a curve for the 2AHS series pumps. It features both the half horsepower and 1 horsepower performance curves of these particular pumps. Now it's pretty interesting to see how from half horsepower to 1 horsepower you're increasing both the pump's maximum pressure rating, which is indicated here on the left hand side by feet and meters, which is up here at the key. So you can see at half horsepower this pump will produce a shutoff pressure of 40 feet. At the 1 horsepower version of this pump at roughly 61 feet, because it's just a touch over 60. And then you can also see on the flow side that the maximum flow rate of the half horsepower is about roughly 56 gallons per minute, and of the 1 horsepower we've got roughly 95 gallons a minute, 96 gallons a minute, somewhere in there. So you can tell that the increase in work is a direct correlation of the flow and head performance of the particular pump. Another thing to take note of when reading a pump curve is that oftentimes it's a good idea to pay attention to the scale of the graph that you're reading, and most often each pump curve is going to have a slightly different scale. The scale on this pump curve is 2.5 feet per vertical square, but 5 gallons per minute per square horizontally. And to give some idea of what this particular pump's applications might be, just to get an idea of where this pump might fall in the big scheme of things, rather, is this particular pump is a sump effluent type pump. It's also a utility type pump. It's primarily intended on moving mostly clean water. And I say mostly clean because it can certainly move dirty water, gray water, and so forth, but it isn't intended for a high degree of solids, sediments, and things of that nature. So let's take a look at a slightly more complex pump curve, and what we have here is another bar mesa pump curve. This is from the bar mesa PS series pumps, and that is a stainless steel centrifugal type pump. And it's an above ground pump, so it's slightly different in configuration as well as how the curve is laid out. This one looks quite different than the curve that we looked at before. It shows a lot of information. First curve that I'm going to point out is this line right here. This line is the performance curve of the pump. So this is going to tell us that this pump can produce a maximum head or pressure of approximately 63 feet. And it's going to have a maximum flow rating of approximately 72 gallons per minute. What this particular curve shows that the first curve that we looked at did not show is the efficiency curve, which is very interesting, and it also kind of proves a very common rule that is applied pretty broadly in the pump industry. When looking at a pump's performance curve, it's generally accepted that the middle of the curve, or roughly the middle of the pump curve, and we're talking again about the pump's performance curve, is that the middle of the curve in most cases is your best efficiency point. Now in this particular pump, you can see that the efficiency curve essentially peaks about right here. So the best efficiency point for this pump is right about 55 gallons per minute at roughly 50 feet of head, or 49 feet of head or so. Now, the general rule still applies that the center of the curve, generally speaking, is going to be the most efficient spot to operate the pump. That generalization comes along on the basis that you don't always have an efficiency curve available, and it's most often the case that the pump's performance and the efficiency curves are going to intersect more closely towards the middle of the curve, because in most cases a pump is designed around that middle point, and then everything else that occurs is essentially just a byproduct. So you can see here that in the high head applications, this pump is not very efficient. However, as we increase the amount of flow that we're trying to push with this pump, thus moving more water per rotation of the pump's impeller, we increase the efficiency until we kind of peak out right about here, and then we start to decrease the efficiency again. So what this curve also shows us is the horsepower requirement in order to achieve the designated flow and head rating for the particular pump. And they do that by showing the horsepower rating on the right hand side here, and then we have half horsepower, 1 horsepower, and 1 1/2 horsepower. And you can see that this particular pump, really there's no reason that you would want a half horsepower, because at no point does a half horsepower achieve the workload of the pump's capability. And they merely put that on there as part of just showcasing the scale of the curve. And what we can see here is once we get into the 1 horsepower, which is this line here, the 1 horsepower essentially can handle from this point of the curve to this point of the curve without any problems, and that would be without overloading the motor. So essentially, when you look at the performance curve, that says that we can operate at 1 horsepower to about 30 gallons a minute roughly. If you needed to get more than that, you would look at the power curve here and say, oh, perhaps I need to operate at 60 gallons per minute on this particular pump curve, and that's a very efficient spot for operation. So what I'm going to do is I need to purchase the 1 1/2 horsepower configuration so that at no point is the motor going to overload in this particular application. And then the final curve that this particular one shows is we have the NPSH up here, and that is the suction head that the pump is rated for at the particular spot on the performance curve. What the NPSH curve represents is the maximum suction lift that the pump is rated for to achieve the flow and pressure rating, and effectively to not cause any damage to the pump during operation. And the damage that can occur by misapplying the suction head is most often cavitation. So what we see here is on the left hand side of the curve, where our flow rate is at its lowest but our pressure is at its highest, we have a maximum suction head of about, well, less than 2 feet. And as we move along, we eventually break 2 feet, and at about 50 gallons a minute we are at about 3 feet. At about 65 gallons per minute, we're at about 4 foot of maximum suction lift. So this is kind of a representation of, as the pump starts to move more water, it becomes a little bit easier for the pump to draw water from a greater depth, and that has to do with the mass and velocity of the water itself as it goes out of the pump. It just gives the pump a little bit more suction, so it's able to draw a little deeper. Now, I really like this particular pump curve as an example because you can really see the detail of information that's offered in this little graph. This particular graph shows the motor speed, 1725 RPM. It shows horsepower requirements. You've got gallons per minute, liters per minute. You've got the efficiency represented here. You've got the head in meters and feet. And this particular pump is offered in 1 1/2 horsepower, because then it's able to achieve the full range of the curve without any fear of overloading. Some other information that can be found on this pump's curve. What you've got is you've got the curve number, so that if you're looking at this and speaking to the manufacturer, you can give them the document ID and they can look at the same document as you and compare and contrast notes. Additionally, you can see that you've got size information, impeller diameter information. So all of this information together gives a person a lot of information as to what they can expect from the performance of the pump. And now looking at this third pump curve, what we have here is another Bar Mesa pump. Now this is an interesting pump. It's a split coupled vertical inline pump. So this type of pump is most often used for pressure boosting applications. And what you can see here is that this pump curve shows a ton of information, but it's laid out quite differently from the other pump curves that we've taken a look at. This particular pump curve shows that this pump is offered in 1 horsepower, 1.5 horsepower, and 2 horsepower configurations, and each one of these lines here on the performance curve is a representation of the horsepower as well as the impeller trim. The 7.5 is a reference of the diameter of the impeller. What we can see from the impeller size is that at a 7.5 inch impeller and a 1 horsepower motor, this pump can produce up to about 28 feet of head, as well as produce a maximum of about 80 gallons per minute, 80 to 90 gallons per minute. Additionally, as we move up in size to 8.88 inches and 10.16 inches, we can see that the horsepower requirement for the 1 horsepower gets cut off, and it can only achieve a smaller portion of this curve and an even smaller portion of the curve above it. And that's where we take a look at where our particular application is going to fall on the performance curve, and then select a horsepower that is suitable to our application. If in the instance of an application where you're never going to exceed 50 gallons per minute, it may make sense to go with a 1 horsepower motor so that you're decreasing the cost of the motor on the system. Now, this particular pump curve also shows the efficiency, but in a somewhat different format. What we see here is the efficiency is laid out by these tick marks: 30, 39, 46, 52. These are the percentage of efficiency for that particular spot on the performance curve. And these kind of have curves themselves, so the most efficient that this pump can be is the center line here of 59. And again, as I mentioned, you can see that on this pump it's relatively true, and this line goes from here down to here as the most efficient point for each particular impeller trim. And that's relatively the center of that particular performance curve. Now, the rule of thumb is, of course, that when you're sizing a pump, you want efficient operation, because these pumps are, in most cases, somewhat balanced for that efficient operation. Operating too far to the right-hand side of the curve can cause premature failure of the motor and extra wear and tear. Operating too far to the left-hand side of the curve, can become extremely inefficient and cause you to waste a lot of excess money on energy costs, as well as damage the pump through imbalanced operation. So it's always recommended that when you're sizing or selecting a pump, that you tend to try to operate within its most efficient range, or you target that most efficient range. In some cases, it can be a challenge to operate extremely efficiently, or to find a pump whose curve matches your application to a T. So the generalized rule of thumb is you go the center point, and then you can go roughly 30% of the curve in either direction, and that's going to be your recommended operating zone. So you've got the best efficiency point here where the highest efficiency is achieved, and then when you take roughly 30% of the curve in either direction and draw an imaginary line, then that's going to be your recommended operating range. And I would avoid operating outside of the recommended operating range on most pumps. Alright, so now that we've taken a look at a number of pump curves, it's time to discuss the next steps to sizing your system or selecting a pump. What we have is a number of videos that we've put together to help you along the way in the process of understanding a system. So take a look in the description below and see if you can't find a video that meets your needs and kind of helps you on the next step of the process. Additionally, take a look at other videos in our channel, and those may help you along as well. If you have any questions, feel free to reach out to our customer service department. Also, don't forget to like and subscribe for more great content. I want to thank you for watching today, and have a great day.